All right, let's jump right in. We hear the term artificial intelligence thrown around literally everywhere these days, right? But how exactly does a machine, which is just built out of code, actually make a choice? Well, today we're exploring a totally foundational concept in machine learning. It's called the decision tree. Basically, it's this highly structured algorithmic flowchart that allows an AI to take a bunch of raw data and transform it into smart, perfectly logical decisions. So, you know that feeling when you're playing a game, you're super low on health, and out of nowhere, an enemy character rushes you at the absolute worst possible moment? I mean, it kind of feels like the game is reading your mind. But actually, scratch that. It's not magic at all. Behind that behavior is some really precise, programmatic logic. So, what we're going to do today is unpack the mechanics driving those smart characters and see exactly how they evaluate their environment to take action. Section 1, Making Everyday Choices. AI logic really isn't as foreign as it sounds. Every single day, you are naturally running your own mental algorithms. Think about when you wake up. You ask yourself, is it freezing cold outside? Yes. Okay, do I have my heavy warm jacket? Yes. Decision, wear the jacket. You are subconsciously following this logical path based on Boolean or, simple yes and no variables. You evaluate the conditions, and then you just act on the results. It's really that simple. Section 2. What is a decision tree? Okay, so formally speaking, a decision tree is a step-by-step method where computers use yes or no questions to categorize data. Honestly, it operates exactly like playing a giant game of 20 questions. Think about it. Asking, is it an animal, immediately eliminates all the non-animals, right? Which naturally leads to the next logical split, something like, does it have 4 legs? Computers are simply executing this exact same process, just at a massive, massive scale, rapidly evaluating all these distinct attributes to narrow down the possibilities. Now, when data scientists actually build these systems, they visualize them using specific nodes. And there are really only two crucial terms you need to know here: branches and leaves. So the branches represent those yes or no questions. Every single time a question is asked, the path splits. Then, the leaves represent the final decision. Once you've run out of questions and arrive at your final answer, boom, you've reached a leaf. It is just an absolutely incredibly elegant, structured way to organize super complex streams of information. Section 3. Example, deciding on a pet. Let's actually see how this builds a logical path with a fun example. Starting right at the top node, do you want a pet? Yep. So we head down the yes path. Next branch. Is it furry? Yes. Does it bark? Also yes. And there we are. We've reached our leaf, our final decision. A dog. As you can see, every single answer dynamically narrows the whole universe of possibilities down to one single verifiable conclusion. But let's take an alternate path to see how the structure adapts. Start over. Is it furry? But this time, let's say the answer is no. Well, that routes the entire system down a totally different branch. The next question isn't going to be about barking because the algorithm already knows that's irrelevant now. Instead, it asks, does it swim? We say no, and the final leaf, a turtle. The whole architecture entirely depends on the input parameters being processed at each specific node. Section 4. Learning from the data. All right, here is the real game changer. In traditional computing, human programmers have to manually write out every single one of those questions. It takes forever. But in machine learning, we don't even tell the computer what to ask. No way. Instead, we feed it massive, massive data sets. The algorithm analyzes all that data mathematically, and it independently finds the specific questions that split the data into the absolute cleanest, most distinct groups. By maximizing the information it gains at every step, it learns the optimal structure all on its own. It's dynamically building the most efficient tree possible, completely without human intervention. That is huge. Section 5. Real-life story. The game's smart character. So let's bring this all back to that game engine we talked about earlier. Here is a logic actually running inside the game. The enemy spots you. Question 1. Is the player close? If yes, it moves down that branch. Question 2. Does the player have low health? If no, meaning you're strong and ready for a fight, the leaf triggers an attack. But if you do have low health, you might think they'd attack, right? Well, maybe the enemy logic says if they are weak too and you are close with low health, the safest leaf triggers run away. It's a tactical choice, born entirely from the rapid evaluation of these structured branches in real time. Section 6. Your preferences. AI's choices. And it goes way beyond video games. This exact step-by-step methodology powers the personalized recommendations we interact with every single day. When a streaming service suggests the absolute perfect movie, or an app queues up a track you suddenly fall in love with, yeah, that's a decision tree at work. Basically, you are the data. Your clicks, your views, your retention rates, they all help the machine learning algorithm figure out the precise questions to arrive at the perfect leaf for you. So I'll leave you with this. Next time an app recommends a movie or a song, ask yourself, what did its decision tree just learn about you? Thanks so much for joining me for this explainer, and I'll catch you in the next one.